Hello everyone, welcome you all. This is our second episode of Learning Dylan Basic. So today then the audio might be noisy. There's construction work going on beside my building. So let's get started. Today we'll learn the basic types and typecasting. What are the basic variable types Dylan have, and how can we cast them? What are the properties type has? So at the beginning they have listed different types and their size. So you have bool types, byte types, ubyte, character. We'll notice same there are similar type names but with a prefix like u and w. There is d and again u. So what does the u translates to? U is responsible for unsigned type. You represent unsigned type, and the characters are usually UTF-8 characters, but if you see W, that means W character is used for UTF-16 characters, and D characters are UTF-32 strings. So we usually don't care actually UTF-16 or 32. We usually use the UTF-8 character sets. Uh, the special thing about types in Dlang is that they have some functionalities. Obviously they are class, but they have some functionalities, like if I have a int variable, we can let's put everything down, comment them out. We can define an int variable like int a, and then a equals to 100. Let's print right line a, compile it and run it. It prints 100. It's okay. The special thing about types in Dlang is they have some properties, like for int we have, for every type we have an initial value and that represent dot init. For int the initial value is 0, let's see, and for float that would be also perfect if we write like int dot init. The default value for float is none. We have some other functionalities for int, like you can print the maximum and minimum. Let me print them for you. Comment this out. Maximum minimum value of int. As int of 32-bit, the maximum value is like this. You see, 2 to the power 32, I guess 31, maybe 2 to the power 31. Our minimum value is negative of that. And if it was a unsigned int, let's see what comes to with the maximum and minimum value. Okay, double of what was in signed integer, as expected. Okay, this was int. Let's check out some functions of float. For float we don't have actually minimum. What we have is min normal. That is the non-zero minimum non-zero value a float can represent in your system. Okay, let's run them. You see the maximum value is 10 to the power 38 and the minimum is 10 to the power negative 38. We have two different special methods for float as well, like float.none and float.infinity. Let's print them as well. That represent the none value and the float represent the infinity represent the infinite value. For every function, for every for every type, we have a dot string of property which which is the name of a string, name as string. So let's check these functions. At my first glance, I thought that a string of might returning the class name of the type, but actually it returns the variable name. Let me What did you expect to return? You expect the string of should return int, right? But it will print C. Did you see? Because okay. So then how we should check the type actually? We can check the type using the type of function, but the type of function returns the type returns the type. It needs to be stored in another variable. We can name the variable by space and the variable name on the right side, and let's print them. Right line mouse value 3. Let's see what turns out to be. It turns out to be 0. The type of function is only can be compared if we have any known type. We can match the type of known variable and unknown variable. Like if we have int value 2, then we can check if the type of 3 is equal to value 2. Value 2. This should true. So even to use type of function, you need to create another variable of the same type, and then you can match it. This will return either the true or false. But there's I found out another better way using the you can use the type of with is function, and that will return the same, I guess. it also returns true. Let's just comment out everything above. But there is actually another function that I found is type ID. The type ID returns the type info class. See, the type of f is double. Acha, acha. Okay, 3.14. Equal to 3. Okay, and the double, let's check what the double is it a string? What is the type ID returning, like string of, is it returning a string, name of something, or anything else? Let's check. So for that we just pass the type ID to type ID itself. Type info D. So type ID returns type info class. Now let's talk about typecasting. For typecasting we have another thing I forgot to mention is the auto keyword. The auto keywords, the auto keyword infers its type from the right hand side of the expression. So if we say like auto b equal to 800, it knows the value in this expression on the right side is int, then it will auto assign the type of b to be int. And then to cast the type we use the cast function and passed the desired type. Like here our b is int but we want to cast it to float, then we can say cast parenthesis and then float and assign it to c. Let's see, for the print statement we are printing the type ID and the value of c. Let's see what is the c has to offer us. Did you see the c is now float and the value is still 800. You can also custom type using the equal sign. We defined a variable float f and then let's predefine variable b to be int and let's try to assign b to f and see what the type ID says about f. It's again float. So we see the cast and the type and the variable name is used for forcefully casting the type. It was all from this slide. Uh, one thing to mention is the assert keyword. Whenever a integer type is created, we know int have a default or initial value that is 0. So we expect a equal to 0. We can assert if it's not, then throw an error. see outcomes nothing because the test passes. If we put anything other than 0, then it should fail. It throws an assert error because our test failed. So I guess that's all from the slide, and if you need more about typecasting type properties, you can see them in advance. I have go through them and found you can create a pointer using the star symbol. Class conversion, the class is defined like this, and you can inherit a class with this syntax, and the casting also works for your custom defined type classes. Okay, there's a lot to go through. That's all for today.